Here we're going to look at two examples of transformations of the cubic function. If you look at both of these equations on the screen, you will see that they look most like the x cubed function out of all of the parent functions I have discussed in a previous video. You can compare to all of these and you got to be able to tell that they look like some kind of algebraic manipulation of the x cubed function. So we're going to go with the y equals x cubed as our base or parent function. And that's for both questions C and D. Transformation-wise, whenever you look at an equation and within the function, so inside of this bracket right here, if I see a plus 2, that means the graph is moving to the left 2. And then a minus 4 would mean 4 to the right. Plus 2 means 2 to the left. So minus means to the right, and it's a 4. So that's 4 to the right. Then at the end of the equation, far out away from the function, all the way on the outside, if we see a minus 3, that means it's going down 3. And then the plus 1 is going to mean that it's going to go up 1. And here is the proper way of writing your transformations. You would say that there is a horizontal translation 2 units to the left. Then there is a vertical translation 3 units down. So you can write down the transformations and then play the video to go along with creating the points for the graph. So now let's go ahead and apply the mapping rule. In question C, I'm going to look at the key points of the x cubed function, which I have done in a previous video. If you don't know, you can watch that. So I look at these key points. 5 key points is more than enough. Because it's an x cubed function, I can look at a couple of negatives, 0 and a couple of positive x's for my key points. And now the mapping rule, which is going to tell us what exactly we do to x. We interpreted a plus 2 as meaning shifting the graph 2 units to the left. So I'm going to go to each x and I'm going to subtract 2 to move them 2 to the left. Then on the y values, we said that this graph of y equals x cubed is going to be shifted down 3 units, down 3. So each y value we take, we subtract 3. So we're going to work these out. -4, -11. And now let's make a scale and plot these. Let's now connect the points. So on the x-axis, each square I'm using a 1 because the x's are just like 1 unit apart. The y values have a more variation. So I'm going to go with going up by 2's on the y-axis. -4 with a -11. So that would be right here. -3 with a -4. That's there. -2 with a -3. -1 with a -2. And a 0 with a 5. So again, if we're going up by 2's, a 5 would be right here. And now I'm just going to connect these key points. And that's going to be the graph of this equation. So like that. And there we go. So that's how you plot this function. Question D. This is how you write the transformations properly. We say there is a horizontal translation 4 units to the right. That's what happens when you have a negative beside the x -4, minus shifts it to the right 4 units, and then having the plus 1 at the end, vertical translation up 1 unit. So once you write down these transformations, you can play the video to continue with the graph. Looking at the same key points of the x cubed function, I want to make the x values go to the right 4 units. So for each x, if I want to shift them to the right, I add the 4. Vertically, we want the y values to go up 1, translation up 1 unit. So here we go. And now I'm going to apply these to each of these key points. -2 plus 4, -8 minus 1, and so on. Okay, so here are all of the key points that are worked out. And now let's make a scale and plot these points. I have my scale ready. Key points, 2 with a -7. So these are the positive values. Again, on the y-axis, I'm going up by 2's, -6, -8. So 2 with a -7, 3 with a 0. X is 3, y is 0. X is 4, y is 1. X is 5, y is 2. X is 6, and then y will be 9. So 6 with a 9 right there. And then we just connect these key points. We go to there, to here, and there's our graph for question D.